of
Back to class.
back. Yes, I'm not going to stop my lesson. We're going to carry on. No halting. I'm very sorry, my dear. All right. I told you, my dear, today's papers that I read, moral plus maths equal to, they said, the maths curriculum. But I'd like to tell you, if you have no moral, no maths, you become what? Moron. You don't want to be one, right? So you've got to equip your skills in maths and make sure you know many things. What we did earlier on was about the lift. It's a real fact of life. The lift moving up, moving down. And in fact, this lift, of course, at a constant speed. Can you imagine? The lift can go up very fast, one point, another point very slow, another point very fast. Then you ask, what developer built this type of lift? That's why my son is now. The lift was moving at a constant speed of 3/2 meters per second, whether up or down. What you can do is that you can rewind the tape, play the game, listen to it, and then maybe you'll have a better and a more sound understanding. It doesn't cost you extra money, does it? Alright? Okay, let's go back to it again. The next question is about a particle being thrown. And this particle, the distance that is moved by this particle is represented as s. S meters. I don't know why I call it s. Okay, anyway, this is just a standard term. We always like to call distance as s or d. Okay, now traveled and the time taken is t seconds are related as follows. This is the beautiful formula connecting it. Now, my dear, if you look at this formula, you can see there's a quadratic equation, do you? Yeah. And it's got a positive t squared, that's a half. So it's going to be a mountain or a valley. It's going to be a valley, yes, that shape. Not this way. When you see a minus t squared, then it will be that way. Now you're going to plot s against t. And from the graph, you have to estimate the speed of the particles when t is 1 second and t is 4 seconds. Now, as I said to you again, all right, you're going to draw it with accuracy. I'll do it, all right, given my space. Okay, because doing it on the board is not as easy. Be a kind soul. Understand why we need that cooperation. Now, let's look at it. Time, 0 to 5. So, where's the time? Here, great. And you put down here, seconds, t, small t, all right? And here is the distance, which is s, and the s is measured in meters. Now that's your y-axis, and this is your s-axis. Look at, before you calibrate, look at the distance, all right? This is 17.5, and that's 0. It's all positive. So the maximum height is up to about 17.5. So calibration, look at it, 2, 4, 6, 8, 10, 12, 14. Not very good. I want to extend my height a little bit more. How organized are you? Neat person? Or a very untidy person? Or in between? Moderation. All right. So in maths, we've got to be neat in our presentation. I like that skill. I like to see neat work. Now we look at time from 0 to 5. This is 0, 1, 2, 3, 4, 5. Now it looks like too short. Maybe I want to make it a bit longer. 1, 2. Okay. So maybe we want to look at the scale. Look at the scale. Draw the scale that's convenient and easy to read. 1, 2, 3, 4, 5 seconds. Okay? From here, we're going to look at the reading and you're going to help me, my dear. 0 is 0. When t is 1, s is 3/2. 3/2 is 1.5 meters. 1 is here, 1.5 is about there. When t is 2, you get 4. Somewhere here, 4. Look at that. And when t is 3, your s is 7.5. 7 is here, 7.5 about there. And when t is 4, you get a 12. Ooh, it's going up very fast, 12. And when t is 5, you get 17 and a half. 17 and a half is here. We've got more or less all the points marked, and it's just a matter of joining them in a smooth way. No need to use curve rulers and all these things. Use your free and easy hand. Make sure it's steady. Just link them up and do it. Okay, you've got a lovely, lovely curve, a smooth curve. In your case, you have a smaller graph, so it's more easy because you've got a less distance to travel. Whereas for me, I've got a bigger space to travel, so take note, there's more inaccuracies here. Now, when you draw a graph, you've got to write the name of this graph. What's the relationship between S and T? S is equal to, write that out, S is half T squared plus T. Now this is a quadratic curve. It's a distance time graph, and you can see from this graph that at every point the speed is changing. Do you see that? Unlike the earlier graph that we did, where we have straight line, dip, dip, dip. Alright, this is a distance time graph. Speed is constant here. No distance moved, speed is 0. Here, the speed is there's another speed this way, just in the opposite direction. So there is a difference between this graph and this shape graph. This is showing you that it's not a straight line, it's a curve. It's a changing speed. And the speed, if you want to find out any point, just draw a tangent. A tangent at that point. What is a tangent? A tangent is a straight line touching the circle or the curve at just one point. It just kisses the curve at one point. Let's look. You're asked to draw from this graph. You're asked to find the speed of this, the speed of the particle when t is 1 second and when t is 4 seconds. Let's look at when t is 1 second. Draw this out. Draw a straight line. Alright? And you look at it and you want to find out what is the speed. You got to notice, okay, you got to get the distance over the time. To get the distance, maybe you want to look at this point. When t is 1, your s is 2. Now I would look at it here. Maybe I'd like to take a point here. Take 2 points. And then from there we work out the gradient. What is going to be the slope when t is 1? Okay, when t is 3, look at when t is 3. I get this point here. T is 3, this slope. And the slope tells you that it's about 6. And I take another point here. Maybe when t is half. And the y, that's the y-axis, your s is 0. So what is the speed when t is 1? What is the speed you want to find out? Now the speed will be equals to, you take these 2 points, any 2 points can read. It's good to make it something that's easy and readable rather than taking a 2.5 and trying to find out. Take an easy point. So look at this, when t is 3, you get a 6. So you say 6, when t is half, your d is a 0. And then look at here, you get a 3 minus a half. So you get 6 minus 0 over 2 and a half. So look at that, and from there find out the speed. You're dividing by 5 over 2. Multiplied by 2, divided by 5. 12 over 5, which is 12 over 5 is 2 and 2/5, which is 2.4 meters per second. That's the speed from this graph. Alright? It may not be very accurate, but of course, if you draw your gradient, it's around there. Okay? Now, those of you who have done A maths, additional maths, you would know very easily without the graph, you can counter check it by doing a differentiation and some techniques, and you can work that out. I'm not going to harp on that because some of you have not learned it. Let's drop that. Okay, that's the speed. You can see that the speed is changing at every point. Let's look at another point. When t is 4, t is 4. Yeah, look at this point, and you want to find out what is the speed Okay, we just draw a straight line. Mark a point. You mark a point. Look at that. Maybe I draw this straight line. I mark a point here. And I mark a point when t is 5. I mark this point. Draw a gradient that touches the curve at one point. When we say that t is 4, that gradient, when it touches at 4, it may touch other parts of the curve because somehow the curve looks quite straight there. So do not get disturbed about it, alright? So let's find the gradient when t is 4. Now that gradient is showing us the speed. T is 4. We take this point here, alright? I look at this point here, we get a 5, and it looks like it's 18 there to me. I look at this point, when t is 3, I look here, it's about nearly 3, it's about 3.5, about there. I put it as 3.5. Okay, so the speed will be here 18 minus 3.5 over 5 minus 3. Now 18 minus 3.5 will be 14.5 divided by 2. Look at it, we get 7.25 meters per second. Do you see that? The speed is increased from 2.4 meters to 7.2 meters. The speed is increasing on this point. At every point, if I were to draw a gradient, the speed is going to change. Now, this is a distance time graph with distance against time. Now, when we have, like the earlier graph that we did, when we have straight lines like that, I'll repeat again to make it clearer. If this is distance against time, and if I have a graph that went this way, this way, this way, it just shows you that the distance is increasing. And here, there is no distance because it's resting. And when I draw a distance time graph that goes like this, ooh, the speed is changing. This is also a distance time graph. It's not stopping, all right? At every point, the distance is changing, the speed is changing with increasing distance. Now, if I have a graph like this, I just want to show you again, reinforce. If I have a graph that goes like this, goes like that, doop, what happened? You are going maybe from your school to your home, from your home to your school. You're taking your own sweet time. And then here you rested for some time wherever you went to, and then you came back, boom, you ran. Your speed is a lot more faster. And in this part, your speed, let's say S1, this is S2. S2 is a lot more smaller than S1 because the same distance is traveled in a shorter time, this length of time. Whereas that distance here, the same distance is traveled in this length of time. So that's a gradual speed. That's no speed. S is 0. This is S is different. Negative does not mean that it is something telling you it's going to stop. Nope. It's just a change in direction. A change in direction, and that's why the speed is going negative. Okay? Now, I hope you got the picture right. When you look at a graph like that, it's an increasing speed. Okay? Increasing speed. The speed is not constant. When you get a graph like this, it's a constant speed from here to here, from this time to this time, resting. Another speed over here. When I show you here, it's a speed that's constant. Slower speed. Alright? No speed. And a faster speed. Got it? Now we will look into more examples, my dear. Alright? Do not get worried when you have to draw a curve. And if your answers are hovering around there, it's just an estimation. It's not that they want you, when they said get your answers from graphs, they want you to just give an approximation. People aren't so cruel to slaughter you and punish you for giving not very, very accurate answers, because this is a graphical representation. Okay? Stay cool, we'll have more sums on this distance time graph. Enjoy your lessons. Take care. Come back to you soon.